Today you join me at Voltempo, a small Birmingham-based British firm with very big ideas in the charging market. In the picture behind me you can see the prototype chargers that they've been looking at there, what they call hyperchargers, capable of up to a megawatt of charging for any vehicle in the future which might be able to accept that. And that may not be as far away as we would possibly think. I mean, they're talking maybe 4 or 5 years down the road. In fact, they have a prototype vehicle here which can actually take a megawatt of charge if it was available to them. So it's been really interesting to talk to people here. The approach they're going is kind of similar to the Kempower approach we saw a few months back, which is the idea of that each of these units is independently just really a cable management system. The actual brains is happening in a box which is attached to them. What's really interesting is, if you look at this picture again, is the plinth they're showing at the bottom there is actually where all the wires go to those units. So it's very easy to replace the units and without having to actually do lots of groundworks. Makes it a very attractive proposition to people. Anyway, we'll be talking to my CEO fairly shortly and get some more information. Hi, thanks for taking the time to talk to me tonight. It's been a really interesting day, I have to say. Looking at your prototype equipment, it's been very intriguing what you're actually doing and some great innovation, I think.
Thank you. Yes, yeah, we've been working on EV charging. I've been working on EV charging systems since 2006. So this is very much an evolution. And back in 2010, I came up with an idea, just a simple idea at the time, for a centralised EV charging hub using battery backs and backup and everything else. And it was at the time there wasn't the vehicles out there wasn't the requirement for it and everything else. But as a concept, it was something that I felt had legs even then. And it's been sort of a journey since then, really, to create a charging hub in a viable way that makes sense for rapid installation across public charging networks and also for fleets.
So what's the unique selling point of your product effectively?
Okay, so what we're doing is, instead of having lots of individual charging points, we've got one big centralised charging system, and we then split that power out to multiple vehicles. So if you've got 5, 10, 20 vehicles you need to charge, one centralised charger, and then a unique distribution system to charge up multiple vehicles from that one charger.
And talk about the distribution system. One thing that really impressed me was the lack of groundworks to do distribution.
Absolutely. So one of the big issues at the moment, if you're putting in lots of charging points, every individual site you're doing is bespoke. So somebody will sell you the charging points, but you've got to design the whole electrical setup for that site, and you're digging holes in the ground and running trenches and putting cables through trenches and so on and so forth. And if you then want to change things in the future, well, you can't. It's fixed to the ground, So our concept was, okay, let's get rid of all that disruption and mess and design a whole system, the whole site in a factory, then turn up on site and drop it off. And that meant, for that to work, we had to get rid of underground cabling. So what we've come up with is an above-ground trunking system with all the cables running through that trunking and then going through to the individual charging connectors, charge points themselves, through that above-ground trunking. So it will look like a footpath, basically, or a pavement in the ground, but actually it's a trunking system. The benefits of that is that you can build it really quickly. The one through there took us 2 hours to assemble initially, so it's really quick. So you could put together a whole site in a day. In that regards, if you want to pick up them in a bit, you can. If you want to reconfigure it, you can. If you want to add more charging points, you can. It makes it very, very flexible for the future.
So like now, when we're stuck with loads of 50 kilowatt chargers, that wouldn't be an issue because you just drop another.
Yeah.
But if something better came along in the future, you just sort it out.
Absolutely.
But you've actually allowed for the future in quite a big way anyway. I mean, the amount of kilowatts you're talking about being able to put through these things seems impressive.
Absolutely. So at the moment, the fastest EV charging out there is 250 to 350 kilowatts, and there's no vehicle out there that can charge quicker than that. but they're on their way. So when you're looking at heavy goods vehicles, then a 350 kilowatt charge, that's still an hour and a half charge time. If you really want that down to sort of 20-30 minutes, now you're looking at sort of 750 to a megawatt charging. So it's going to be needed. So in our system, the central core can be up to a megawatt, and in future we'll have higher, so to 2 megawatts and even 4 megawatts in the future as well. But at the moment, of course, nobody can charge at a megawatt, so that's why splitting the power out works well. So if you can imagine a site where you had maybe 20 heavy goods vehicles, Eddie Stobart's this world don't have one truck, they have 20 at a site. So you say, right, okay, we'll have a charging system which can charge 20 vehicles. And to megawatt central charger, that means that each vehicle on average, it takes 50 kilowatts. It takes all night to charge, but that's fine because you're only allowed to, as a driver, you're only able to use your truck for 10 hours or so a day anyway. So you've got plenty of time to charge up slowly. But during the day, if your truck driver turns up, you want to turn him around and get him out quickly. So you then put 350, 500, 1 megawatt of power into that one vehicle and charge it up and get it on its way quickly. So that's the logic. You need to be able to use your charging systems in multiple ways. But of course, also electric vehicles. We know that the batteries have been getting bigger and bigger over the last few years, and that will continue. But what we're also seeing is the batteries themselves can be charged faster. So at the moment, typically, it doesn't matter whether you've got a Nissan Leaf or a Jaguar I-Pace or a Porsche Taycan, from flat to full takes 35 minutes to charge up, give or take. So the batteries themselves aren't being charged any quicker, it's just you've got a bigger capacity of power because you've got a bigger battery to charge in the first place. But what we're going to start seeing is those charge times themselves start to drop. So we had an investor a couple of years ago who said, look, where's this going? At what point do we get down to charging at the same time as you can put petrol into a car? And we thought, well, okay, technically the cells are available at the moment to do that, to charge in 6 minutes. But actually putting that together into a pack, into a vehicle, and then creating the charging system that can work that fast, and the currents we're talking about, 500, 800 amp type currents, how do you manage that? So we built a battery that could charge that quickly using lithium titanate cells. It was a prototype. It isn't. Don't expect us to go down to your dealership tomorrow and buy a car that can charge this quickly. We built a pack. We put it into an electric truck, and we built a charging system that could charge that quickly. Now it's scaled down, but we now know how to charge at 800 amps easily. Now that sort of information is going to be really useful for when you're charging up your trucks in 20 minutes or 10 minutes, charging cars in 6 minutes. In the future, charging ferries, cross-channel ferries and shipping, aircraft. An aircraft on the ground is an expensive thing. You want to charge it quickly and get it out there. So we've got a system that is scalable so that you can charge vehicles in that sort of time. And we think that for niche applications, we could potentially see vehicles on the road that can charge that quickly within 3 to 5 years. For example, ambulances. Ambulances don't drive 200 miles to go to pick up a patient, take them to the hospital. They do short journeys, but they use 24/7. So you need to be able to recharge really quickly because you need to be able to use that vehicle straight away. So you look at an ambulance, they go out, they pick somebody up, they take them to the hospital. The ambulance then goes to a cleaning area for 15 minutes to be cleaned and restocked before it goes out again. That's 15 minutes to recharge the vehicle. If you can recharge in that time, you can keep using that vehicle 24/7. There's other applications, not just for the blue lights like ambulance and police and fire, but for airport shuttles where you have a bus. They don't drive 200 miles. They go to car park 1, car park 2, car park 3, and then the terminal, and then they're back again. But they're doing that for 20 hours a day. The problem with an electric bus is they cost £100,000 more than a diesel bus. So the payback on it is really, really difficult.
That's the battery, isn't it?
And a lot of that is down to the battery. But if you could have a very much smaller battery, but keep charging it up, 30 times a day, or 20 times a day, or whatever, now you can get the price of the battery down, so it's the same as the diesel vehicle. So suddenly you've got an unlimited range, if you like, because all you're ever doing is very short distances. But you've got the use that you need out of it, but you've also reduced the cost of the hardware, so you can get electric vehicles into sites which have been cost prohibitive up till now.
Yeah, that's a really good use case.
It is.
I do remember talking to someone from the University of Oregon a few years back about, and he was arguing that actually the best approach with electric vehicles was smaller batteries rather than big batteries, and have fast charging and lots of it. Now, obviously, your infrastructure is really suited for sort of, I think, of a service station. So, can you just the delivery? I was thinking different dwell times, for example. I mean, there's different scenarios where you wouldn't want necessarily to charge quite that quickly.
Yes. Yeah, so absolutely. So we can set things up so there can be a maximum charge speed if you want to slow everybody down. So if you wanted to put charging in and you've got a number of shops, for instance, you want people to go shopping for half an hour or whatever, you could adjust it to slow it down if you wanted to. But also you could set up priorities. So if you wanted people to be able to pay extra to get a priority charge, then you could do all of that in there as well. So there's all sorts of things you can do to make it cost justifiable for different cases.
And I know you've also done a lot of look at the grid supply, because obviously there's big challenges there.
Just a few.
We were talking about some on our show a couple of weeks ago. The motorway services particularly are a big challenge because of where they're located.
Yeah.
Most of them are between conurbations and not actually, and a lot of them haven't got very good grid supplies at all.
Correct.
For what they've already got without taking EV charging into the mix. And your system allows to enhance that, I guess.
Absolutely, yes. So most motorway services, they've got the charging they've got, whatever it happens to be. If you wander around the back of the services, more often than not, you'll find a diesel generator there.
Yeah, which is good.
Yeah, absolutely. So and they're big ones, they're not little ones. So quite often you'll see this building and there'll be a rumbling sound from inside it, and that's our power station. It's running on diesel. So that happens at an awful lot of sites. So not great. But of course, most motorway services are busy during the day and they're quiet at night. Okay, so and because they're in the middle of nowhere, they're surrounded by green fields. So why don't we cover some of those green fields with solar and some batteries, and you could have entirely 100% green energy, EV charging, because you've got a big solar farm next door. So what we have within our system, because we've centralised the power system, we can manage the multiple power inputs centrally. One of the biggest issues, we put a system in at an airport a few years ago, and we put in batteries to go in with the grid because the local grid wasn't powerful enough. And the problem was with individual charging points, they ended up fighting each other for the available power. And you see this with charging points today, where you've got 5, 6, 10 charging bays. They might be advertised as 150 kilowatt chargers. You plug in, you get 40 kilowatts. And you think, why? And it's actually because the chargers themselves are fighting each other for the available power, and it brings all the chargers speeds down really, really dramatically. Our system doesn't do that because we have one central system which then splits the power out. You don't get that fighting. But we also have a patented system for 2 power inputs. So one can be the grid, and the other one can be something else. So that could be batteries, it could be a solar farm, or both combined together. In a worst case scenario, you could actually have a system where you have a diesel generator to boost the grid. But what you could then do, for instance, firstly you'd use biodiesel, or you'd try and find a better fuel for that, but you would prioritise the grid. If the grid can't cope, you'd have a battery pack in there as well, so that the grid could trickle charge the battery at quiet times. So the battery then delivers more power, and if that runs out of power, runs out of energy, then you kick up the diesel generator, which provides the additional boost of power there as well. So yes, you still have diesel generation, as we already have at motorway services, but at least you're doing it far, far less. In the medium term, you'd hope that the grid can either catch up, or you've got time to put your solar farm in. So that means that you can put something in right now today, and it might not be as green as you would like it, but it's there, and you can be getting the green plan in place at the same time. You can rent generators by the week, so you put something in quickly, but then get rid of it as quickly as you possibly can as well. So it's a step, if you like, a stepping stone. We've got that opportunity if required.
So to take any source of energy into it.
Absolutely. Absolutely.
Clever stuff. So where are you in the development stage at the moment?
Well, we finished our main development, so we have a prototype system running here in Birmingham, which is currently for 3 vehicles. We're using that to fine-tune the software side of things. So we've got our software developers getting the management systems completed on that. We will be putting in our first system into Tyseley Energy Park in Birmingham at the end of April, and that will be initially for 4 vehicles, and then we'll expand that to 12 in June. So that's the time frame for our first system. And in terms of rollout, we're talking to a number of customers, and we should have our first customer sort of sorted out in the next couple of weeks for a rollout across. Well, it's either going to be in Wales or it's going to be in the Midlands. It's going to be our first customer.
People in Wales would love that because it's always seen as a bit of a charging.
It is, yeah. I'm getting married in Wales at Easter, and the place we're getting married at, there's no rapid charging within a 30-mile radius of where we're going to be. So
it's a
not
challenge.
good.
So actually, while we're talking about installers, I mean, for installers, you've got some amazing tools. I was blown away by your spreadsheet. I can see this. So you've had some installers and people around playing today, and I can see that they were really impressed by your charging. But actually, the ability to analyse the infrastructure that you have in your spreadsheet was the thing which really blew the.
Well, yeah, I mean, we've got a big issue as an industry. We need to put in charging systems in really, really quickly. The rate of installation at the moment just isn't fast enough. So we can do that in 2 ways. In terms of the manufacturing side, we manufacture the whole thing in a factory and then bring it to site and drop it off, rather than sort of designing every site individually. That speeds that up. But it's also important to identify the right sites in the first place. So if you look at where petrol stations are today, some of them are in perfect locations for EV charging points, but a lot of them aren't. And you need a different type of location. So we've got a tool that allows you to, you type in the postcode of a site, you can identify where the site is, you can do a rough layout of where you want the charging points on that site, work out where all the cables need to go. You can then link into the national grid to find out where the local substations are and where the cables are, and so on and so forth, so you can work out if there are any issues on that side, have you got the capacity to do it, and if so, what the likely cost is of putting the system in there. You then analyse how many vehicles are driving up and down the road next door, and when they're driving, with daytime, evening, nighttime, weekends, all that sort of stuff. And from that you can identify how many of those vehicles are hybrid, plug-in hybrid, and how many are full electric. And we can then estimate what those figures look like for the number of vehicles on the road going forward to the next 20 years. So, because obviously that number is going to go quite rapidly. So from that we can then say, right, okay, approximately 2% of all battery electric vehicles and 0.2% of hybrids would like the ability to charge up at that site. And you can change those figures depending on what site it is. You can then say, right, this is how much profit I want to make on my electricity when I'm selling it, and it will then work out what the payback is of putting the charging system on that site for the next 15 years. So you can see whether it works or not. Now, the whole process takes 15 minutes. Now, everyone else who's been working on that sort of system telling me that takes 2 to 3 weeks per site to do, and we can do it in 15 minutes. So if you have a company that's got 50 forecourts, 200 forecourts, whatever, and they want to analyse them, we can do it really, really quickly and identify what the benefits are, what the payback is, and so on and so forth. And what we're finding is, in most cases, if you've got a petrol forecourt, you can earn more money by putting in EV charging into a proper hub than you ever can selling petrol.
Because the margins of petrol
The margins on petrol are poor, and in fact, even if you're only making sort of 10 pence per kilowatt hour on electricity, you're making more than you are on litres of petrol, so very quickly you've got a very profitable model there. And of course you've got people there for sort of 20 minutes to half an hour, so you can sell them coffee and all these sorts of things.
Which have even bigger margins.
Which have even bigger margins. And that means that the petrol station of the future is going to be a very different type of model than it is today. It's going to be more like a miniature version of the service station you get at motorways. There'll be things you can go and eat. It's going to be shops to browse in and all those sorts of things to make it a much more friendly place to be rather than the rather austere petrol stations we have at the moment.
Yeah, and that again comes down to sort of dwell times. And then we talk about. There's always been this thing about getting it to charge as fast as you fuel, but actually in some ways you don't want to do that because most of the times with an EV driver, being an EV driver, when you take a break, you charge when you do something else.
Yes.
You don't make a trip to go charging. Unlike a petrol car, where you tend to go make a trip to get petrol.
Yes.
Charging occurs where you are.
Yes.
When you've got to. So I think that's quite an interesting concept. And,
it is. Yeah.
And I know talking to some people in the industry, the idea of actually very fast charge times is something they almost don't want because the revenue streams are lessened.
Indeed, but at the same time, what we've had with EV charging up till now is that EV charging infrastructure has always been chasing the cars. They've not been as quick as the cars. So I can't believe that people are still installing 50 kilowatt chargers, and they are. Yet every electric car available on the market today charges quicker than 50 kilowatts.
Yeah.
And if you've got a car with a 100 kilowatt hour battery, you're charging for 2.5 hours or so to charge it from 50 kilowatts.
Which I think is where the point comes in. If you can charge fast, then you can expand the battery size, which means again you've got that longer journeys before you actually need to make that.
Absolutely. So and there are companies. There's a startup company at the moment called EV Centres, who are looking at the idea of what does a petrol station of the future look like? And it's similar to what GridServe are doing, but on a smaller scale, so it can be rolled out more quickly. So they're looking at sites where you always have somewhere to eat and drink. There'll be a business centre potentially, a park for the kids perhaps, a farm shop. And making it local so that it feels like when you go to somewhere, it's a little bit of an occasion to go there. And their research suggests that people will want to spend half an hour there. So actually, you might end up staying longer there than your car needs.
Yeah, actually, it happens to be all the time at the moment.
Yeah, absolutely. So, but on the other hand, if you've got an electric car and you've got somewhere to be, and let's face it, if you're on the road, you've got somewhere to be, then you want to get that charged up as quickly as possible. So that the ability to plug in and charge in 6 minutes and clear off again is going to be important.
I guess that's an option. It makes some sense in some.
Yeah, the way you would do that and the way you put it on our system is you say, right, okay, for most people, most cars will charge in half an hour, so we'll base it on that. If you've got a car that can charge in 6 minutes, you can pay a premium and have rapid charge, and that's so that way on the occasion you do need to charge really quickly and get out, you'll be able to do that.
Which makes a lot of sense.
It does.
Because obviously then that offsets the loss of revenue for you, the cafe or whatever's okay. Yeah,
absolutely.
Clever stuff.
Yeah.
So all of this is really clever stuff. I've been very impressed with what I've seen so far. So let's just talk about your actual charging infrastructure. So obviously each of the boxes is fairly done in its own right because everything's in the container.
Absolutely.
So they're more or less just cable containers, is it?
Pretty much. Yeah. So there's a small controller because you've got the screen on there, and if you're the payment system, so for credit card payment and everything else, that would be built in onto that as well. But the vast majority of that space inside is fresh air, and the reason for it being fresh air is that you want to be able to want the cable to retract inside the unit when it's not in use. So a lot of charging points today, you end up with cables strewn all over the floor and it looks a mess, and the cables drop on the floor and the connectors get damaged. The number one reason for rapid charging points being out of commission is because the cables are damaged and the connectors are damaged. So what we wanted to do is to be able to have the cable retract out of the way and when it's not in use. So we spent a lot of time working on getting that design right. Some little tweaks still to do, but we're pretty close now. And it keeps it neat and tidy, and it also keeps it safe.
Yeah.
So, and the other element of that is the styling we have on it at the moment. we can customise it. So if you have a customer who wants something different, they want their own branding on there and everything else, or different shape or whatever, we can change that very, very quickly. So and design something different.
Well, I guess actually that's a very valid point. The fact that you're not having to put lots of electronics inside it means you can come up with varied shapes.
Yeah, absolutely. So we can come up with something different for a multi-storey car park, for example. And we also have the ability, potentially, if we could have the system containerized, 20-foot container with the charging points, charging handles on the container itself, so that you cluster the vehicles around the container. So if you're a fleet, for instance, and you wanted to be able to trial EVs within your fleet, you needed to have some rapid charging facilities in there. We could pick up a container, take it to the site, drop it off, connect it to whatever grid's available, maybe back it up with a generator or batteries, and you can trial EV charging. Or if you were at motorway services and there was a major power system failure or whatever, we could have a backup system delivered on site within the next day or so, and you could keep going. So it gives us some flexibility of what we can do there.
It's interesting. A lot of the conversation I have around public charging, but obviously fleet charging is equally important. And you mentioned the A-Snowbots of the world and commercial vehicles, I think, are going to be a big area of expansion.
It is, because you can't slow charge a heavy goods vehicle. You've got a 400 kilowatt hour battery, you plug that into your 13 amp socket, then 4 weeks later you're fully charged. It's 3 to 4 weeks, it's crazy. So you have to have DC rapid charging in that. Now, from a public charging point of view, you put motorway services rapid charging in for HGVs, your return on investment is huge. You can get the payback in 2 years, 2 to 3 years, simply because each battery can take 300, 400 kilowatt hours of electricity, so the revenue is significant. But also from the your truck depots and your overnight stops and things like that, having a flexible charging system in there is important, because you need that ability when the trucks get bigger batteries and can charge more and need more power. You need to be able to deliver that. The Tesla semi heavy goods vehicle is rumoured, and it is only a rumour, to be able to charge at 1 megawatt, just under. And ours is the only system that you can charge that fast at, other than potentially some of the stuff that Tesla are working on behind the scenes. But within the next year or two, we could have trucks and heavy goods vehicles charging at that sort of speed. But you wouldn't need that all the time. So you could have the one system that could charge 20 vehicles at night at 50 kilowatts each, that's a megawatt. And then during the day, when the truck turns up and needs a quick splash and dash, you can provide that as well.
Yeah, which is really important, I think. Yeah. All right, so thanks so much for your time today. That's been
my pleasure.
And I have really enjoyed seeing what you've done, and it looks really impressive, and I can't wait to see it actually going into production and out there.
Fantastic.
So we'll catch up later on and see how you've got on, but I think it's really good. Thanks for your time.
Thank you very much.